Many of the applications that we run, be it a web server or PHP FPM or a database server, are designed to be exposed to the outside world in some way. While in a traditional stack, we might use something like a Unix socket, just about all of the services that we will use as a web developer will also expose themselves through some sort of network connection. In fact, in the legacy linking video, we take advantage of the fact that PHP FPM can expose itself to the outside world via a port, like the default port of 9000, and we can have containers talk between themselves. Since Docker assigns a network interface to each container, we can expose those ports to other containers and even through the host. There are a few different ways of doing this. What we've looked at thus far are the default ports exposed through the Docker file, which is something that we will explain in depth in a later video. In short, the Docker file is the instruction set that Docker uses to create an image. One of the options available is an expose command, which takes a list of ports. Here we have a Docker file for the Nginx container. On line 25, we tell Docker to automatically open up port 80 and port 443. Whenever we create an Nginx container, we can then access these ports by going to the IP address of the container. Docker then knows to open these ports and make them available. While we can expose ports through the Docker file, we can also expose ports through the Docker run command. There are two flags we can use, --expose, which mimics the expose command in the Docker file, and the -p flag, which allows you to map a port on the container through the host machine. Let's look at a simple example with --expose. Let's create an Ubuntu container and expose port 9000 by adding --expose 9000 to the Docker argument section of the Docker run command. If we check Docker PS, we can see that port 9000 is available on the container. Let's start up a netcat session inside the container and have it listen on port 9000. I can then connect to that port from another window and telnet into the container using that port. If we hadn't passed the --expose flag, we would not be able to reach the netcat listener. The -p flag works a little bit differently. It will expose the port, like --expose will, but it will also map it to a port on the host machine and make the container available to the outside world. -p has two formats. You can either use automatic port forwarding or specify a port forward scheme. Let's start up a container and allow Docker to randomly select a port. If we check Docker PS, we can see that port 9000 is exposed, but we can also see that it was bound to all the available interfaces via the 0.0.0.0 address and assigned a random port. We can now access this container through either the container IP and port 9000 or localhost and that random port. Most of the time, we want to be able to control the external port that is forwarded, and we can do that with -p as well. We can specify -p, a host port, a colon, and then the container port. We'll expose port 9000 on the container and port 8080 on the host, and telnet into both. The -p option is a great way to start running containers on remote servers and access these containers. There are a few other tricks you can do with -p. You can use it along with the IP to specify an interface to join to, or specify both an interface and an external port. If your container is already exposing some ports, like the Nginx container, you can also use the -P option to map all exposed ports to a random host port. Now that you can take advantage of exposing your application through ports, linking them together becomes more and more easy, and exposing your applications to the internet is now possible.